So we are going to solve a small problem based on adiabatic process. Okay. So what is the problem? There is monoatomic gas filled in a cylinder. This is the diagram. This is the cylinder and this is a piston. Okay. Frictionless piston. This is a frictionless piston. This is a cylinder. Cross section area A, and this height is L1. Okay. So in initial condition, this is the state 1. The temperature is T1, pressure is P1, volume is V1. And suppose there is a force F. Because of that, this piston is on rest. Okay, this piston is not moving. Because of this gas, you are getting pressure in this direction. To balance this, I have to put another force F over this piston. So this piston is not moving now. Okay, and this can be considered as the equilibrium condition. Now what happens? Suddenly I remove force F. So what will happen? This gas will expand. Suppose this gas will expand and this piston will reach at this position. Okay, and at this position it comes to rest. So new length is L2. Area will be same as A. And new condition will be T2, P2, V2. And this process is the adiabatic condition. This is given. Means it is given in the question, this gas can expand adiabatically only. Okay. So this is the condition. So what they are asking? T1 ratio T2 is the question. Now I am repeating question again. I am not going to write a complete language of this question. With this figure, I am going to explain the question. There is a cylinder, cross section area is A, length is L1 in which gas is filled. The initial state, the temperature is T1, pressure is P1, volume is V1. This is a frictionless piston, and to balance this pressure, I am putting external force F. Now what I am doing? I am removing this force. Because of this force, by removing this force, this gas will expand. With help of common sense, you can understand. If you remove this force F, obviously this gas will expand. So when this gas will expand, it is reaching a new height L2. Cross section area will be same as A, and new thermodynamical quantities will be T2, P2, V2. Okay, and this is a piston. They are asking relation between T1 and T2. Means they are asking ratio of initial temperature and the final temperature. So we know equation PV to the power gamma is a constant. For adiabatic process, PV to the power gamma is equal to constant, or I can write as P1 V1 gamma, P2 V to the power gamma. But they are asking relation for T. They are asking relation for T. So obviously we have to remove one, P or V, and we have to substitute that value in terms of T. So we can get temperature in this equation. So I am going to remove this P, this P1 and P. Why? Because we have the cross section area and we have the length, so we can find the volume. Okay? We can find the volume. So I am going to remove this P1 and P2 in terms of T. So ideal gas equation PV is equal to nRT. From this P1 is equal to nRT1 divided by V1 and P2 is equal to nRT2 divided by V2. Substitute this value here in this equation. This value here, this P2 value here. So you will get nRT1 divided by V1 to the power gamma is equal to nRT2 divided by V2 to the power gamma. nR cancel out, T1 V1 to the power gamma minus 1 is equal to T2 V to the power gamma minus 1. You will get T1 divided by T2 is equal to V2 divided by V1 to the whole power gamma minus 1. Now this is equation suppose 2 and this was equation number 1. Okay. Now see here. V1 is equal to cross section area A into L1. What is V1? Volume of this section. So cross section area is A and height is L1. So I can get volume as A into L1. Similarly, V2 will be A into L2. So V2 divided by V1 will be L2 divided by L1. This is one part. And for monoatomic gas, we know the value of gamma, that is 5 by 3. So now put all these values in equation 2. From equation 2, T1 divided by T2 is equal to V2 divided by V1 means L2 divided by L1 and power is 5 by 3 minus 1. So you will get T1 divided by T2 is equal to L2 divided by L1 to the whole power 2 by 3. This is your answer. चलो हम सी क्वेश्चन ये वाला क्वेश्चन सॉल्व करते हैं. क्वेश्चन क्या है, एक हमको थर्मोडायनामिकली कर्व गिवन है P and D, प्रेशर एंड वॉल्यूम कर्व, प्रोसेस साइक्लिक प्रोसेस है, ऐसे A to B, B to C, C to D. और क्या क्या गिवन है? गिवन है A to B प्रोसेस. कौन सी प्रोसेस है? आइसोथर्मल प्रोसेस. B to C कौन सी प्रोसेस है? आइसोबैरिक प्रोसेस. एंड C to A आइडियाबैटिक प्रोसेस. ये प्रोसेस गिवन है इसका. वो पूछ क्या रहे हैं? ड्रॉ PT कर्व. प्रेशर टेम्परेचर कर्व ड्रॉ करने के लिए बोल रहे हैं. इस कर्व पे ऐसे ग्राफ की हेल्प से तो ड्रॉ कर लो. दिस इज प्रेशर और ये टेम्परेचर. अब स्टार्ट करते हैं A to B से. A to B कैसी प्रोसेस है? आइसोथर्मल प्रोसेस है. A to B आइसोथर्मल प्रोसेस है. मींस टेम्परेचर कांस्टेंट है. इसका मतलब क्या होगा कि अब जो A to B इसमें ड्रॉ होगा वो T इसमें कांस्टेंट होगा, उस तरीके से ड्रॉ होगा. मतलब वो जो लाइन ड्रॉ होगी वो P एक्सिस के पैरेलल होगी, नहीं होगी. ऐसी लाइन ड्रॉ होगी तभी तो बोल सकते हैं टेम्परेचर कांस्टेंट है. जो भी वैल्यू होगी ये वैल्यू होगी. क्योंकि अगर यहां से देखें आइसोथर्मल प्रोसेस है तो यहां पर टेम्परेचर TA है, यहां पर टेम्परेचर TB है. तो TA इज इक्वल टू TB. और यही पॉइंट हो सकता है टी इक्वल टू टी बी। ओके, अब दूसरा डाउट क्या है, ये पॉइंट ए होगा या ये पॉइंट, मतलब ए और बी में से कौन सा होगा, ए बी होगा या ए डी ऐसा होगा। तो दूसरी ए टू बी जाने पे प्रेशर कैसा होगा, कम होगा ना। अगर मैं यहाँ प्रेशर बोलूं पी ए है, यहाँ प्रेशर पी बी है, तो क्लियर इस ग्राफ से दिख रहा है पी ए इज ग्रेटर देन पी बी। यहाँ दिख रहा है ना पी ए, दिस वैल्यू इज पी ए एंड दिस वैल्यू इज पी बी। पी ए बड़ा है पी बी छोटा है, तो ऑब्वियसली ये पॉइंट हमारा बी होगा, ये पॉइंट ए होगा। तभी तो इसके रिस्पेक्ट में जो प्रेशर आएगा ये पीबी होगा और ये पीए होगा, और पीए पीबी से बड़ा होगा। अब ये हो गया अपना एबी ऐसी प्रोसेस होगी। दूसरा देखो बी2सी क्या होना है, बी2सी कैसा है, आइसोबैरिक प्रोसेस है, मींस यहाँ पे पीसी प्रेशर है, पीसी है वो टीबी के बराबर है। B2C isobaric process means PB is equal to PC है, प्रेशर कांस्टेंट होगा, उसी को बोलते हैं आइसोबैरिक प्रोसेस। तो अगर हम इस हिसाब से देखें तो जो PB है वही PC होगा, यही तो अपना PC है। अब दो ऑप्शन है, सी साइड हो सकता है, सी साइड हो सकता है। मींस अगर मैं लाइन ड्रॉ करूं तो ऐसे ड्रॉ कर सकता हूं, साइड ड्रॉ कर सकता हूं। तो देखो भाई B2C जाने पे हमको प्रेशर वॉल्यूम में क्या होता है, वॉल्यूम में कमी आ रही है, और जब प्रेशर कांस्टेंट होता है, कांस्टेंट प्रेशर, तो यहां पे क्या इक्वेशन बनती है, B प्रोपोर्शनल टू T होता है कि नहीं होता है। आइसोबैरिक प्रोसेस में यही तो इक्वेशन होती है, प्रोसेस इक्वेशन B प्रोपोर्शनल टू T। अब B प्रोपोर्शनल टू T है, B2C जाने पे वॉल्यूम कम हो रहा है, तो ऑब्वियसली T भी कम हो रहा होगा, नहीं हो रहा होगा, दोनों लीनियर रिलेशन में है। अगर वॉल्यूम कम हो रहा है तो टेंपरेचर भी कम हो रहा होगा, तो C आपका इस साइड होगा, यहाँ पर आपको टेंपरेचर मिलेगा TC और TC will be less than TE और ये पॉइंट अपने होगा C, प्रोसेस होगी ऐसे A to B, B to C। अब हमको ड्रॉ करना है C2A। C2A कैसा है, आइडियाबैटिक प्रोसेस है, आइडियाबैटिक प्रोसेस है, ऑब्वियसली आपको तो ऑप्शन बचा नहीं, लीनियर खींचेंगे पॉसिबिलिटी होगी नहीं, तो हमारा ग्राफ कर्व में ऐसा आएगा, चलो टच करेगा, ये अपना होगा C2A। अब इसको दूसरी तरीके से चेक करना है तो वो भी बता देते हैं। इक्वेशन क्या होती है कि P पावर गामा कांस्टेंट, हमको कर्व कैसे खींचना है, P और T के बीच कर्व खींचना है। P रहेगा, V को हम चेंज करेंगे आइडियल गैस इक्वेशन यूज करके। आइडियल गैस इक्वेशन क्या होती है, PV is equal to nRT, तो यहां से V is equal to आ जाएगा nRT divided by P। Put this value of B here, तो P into nRT divided by P whole power gamma constant। अब गामा की पावर nr पे भी आएगी, nr कांस्टेंट, इसकी पावर एक कांस्टेंट ही आएगा, तो हम यहां पे लिख सकते हैं P, अगर इसको आप सॉल्व करेंगे तो मैं डायरेक्टली लिख रहा हूं 1 माइनस गामा T की पावर गामा कांस्टेंट। आप देख लीजिए T की पावर गामा आएगा, ऊपर जाएगा पावर माइनस कर दो, इसको मैं इस साइड लेके आ रहा हूं, तो ये T की पावर गामा इज इक्वल टू कांस्टेंट P की पावर 1 माइनस गामा, और इसको मैं ऊपर लिख दे रहा हूं, तो P की पावर गामा माइनस 1 कांस्टेंट। मींस हमारा रिलेशन है T की पावर गामा इज इक्वल टू P की पावर गामा माइनस 1 कांस्टेंट। ये हमारा रिलेशन है, तो आप यहां से देख सकते हैं ये कोई लीनियर रिलेशन नहीं है, तो ऑब्वियसली कर्वेचर आएगा। अब आप पावर के हिसाब से देखिए T की पावर गामा है, T की पावर गामा माइनस 1 है, P की पावर कम है। तो जैसे जैसे T ज्यादा बढ़ेगा वेलोसिटी बढ़ेगा बट कम स्पीड में बढ़ेगा। तो आप देख सकते हैं छोटे T में अगर हमने T इतना बढ़ा दिया तो T कितना बढ़ेगा, सिर्फ इसी हिसाब से देखा जाए। अगर छोटे गैप में लिखा जाए तो T का चेंज कितना होगा, उसका कितना सा ये वाला चेंज होगा, T का इतना सा गैप हो गया होगा, या इसका और थोड़ा सा इस हिसाब से राउंड बना सकते हैं, यहाँ से और क्लियर हो जाएगा आपको। ओके, बाकी इन दोनों पार्ट से आपका ऑप्शन क्लियर हो जाएगा कि हमारा ऑप्शन कौन सा सही है, चार ऑप्शन गिवन होंगे। बाकी तीसरा चेक करने के लिए हमने एक क्वेश्चन बनाया कि हमारा जो हमने जो बनाया है वो कितनी सही है, इस तरीके से देखा जाए सही है, क्योंकि जो हमारा इक्वेशन है वो लीनियर इक्वेशन नहीं है, तो ये कर्वेचर आया है, कर्वेचर की पॉसिबिलिटी ऐसी ही होगी। अगर इसको आपको चेक करना है कि कर्वेचर बिल्कुल सही है तो आपको इसको फिर डेरिवेटिव्स के हिसाब से देखना पड़ेगा, जहां डेरिवेटिव्स के हिसाब से आप इसका स्लोप चेक करेंगे, वो स्लोप जो होगा वो इंक्रीजिंग है, इसका जो स्लोप होगा वो इंक्रीजिंग होगा। ठीक है, आप इसको देख लीजिए। थैंक यू। हाय, सो आई एम टेकिंग वन क्वेश्चन based on mechanics, or you can say the simple harmonic motion, and it includes small concept of electrostatics. Okay, now try to understand this question. There is one spring having a spring constant as K, a small block having mass M, and it is charged with charge Q, small q, and there is external electric field in this direction. Okay, so what will happen? Because of this electric field, this block having charge, and because of this electric field, this charge will feel force in this direction. All of you know, if there is a charge Q in an external field, then there is a force F is equal to QE. Okay, so this block will get an electrostatic force, and because of that, this mass or this block will move in this direction. But definitely when it is moving in this direction, there will be restoring force due to this spin. Okay, so this block will move up to a limited value, after that it will come back. So this type of motion will happen in this. The question is, find out maximum extension in the spring. Second one, distance of mean position. Third one, find out is it SHM or not. Fourth part is amplitude. Fifth part, time period of motion. I am explaining this question again. There is a small block M, okay, having charge Q, there is external field E, there is a spring attached to this block having a spring constant as K. Because of this external field, this block will get a force, that is called an electrostatic force, in this direction. Because of that force, this block will start moving in this direction, but up to a value, suppose that value is x, okay, up to a position here. Then because of this spring, it will feel some restoring force, and this block will come back to its position. I don't know, up to this position or at any other position, but we will find out. Okay, so this block will move like this. Okay, so we have to find maximum tension in the spring, means up to what limit value of x this block will move in this direction. Distance of mean position, we will discuss this part during the solution of this question, and we will find out SHM or not. Okay, and all these parts. So I am going to solve all these parts one by one. Okay. Now see, if I draw every of this block, so this is M having charge Q, so it will feel force F that is equal to Q E. Okay, and it will feel force, spring force F as I am writing as spring force in this direction. Suppose what I am going to do, so this is this position. Let me draw just like this, okay? So you will not get any confusion here. So this is spring, this is the initial position. I am writing this value as x for, okay? And suppose this is x2. So what I am saying, this is x2, this is the maximum extension in this spring. Now see how to get x2. You can see this block is moved from here to there. So definitely there will be work done due to electrostatic force. The same work done will be converted as spring energy in this spring. This spring is stressed, so definitely it is having some energy. It is getting some energy, potential energy. From where it is getting that potential energy? It will be because of this electrostatic force, because it is moving up to a distance x2. Or you can say in other word, okay, let's think in the same way, 1 upon kx square, that is energy gained by spring. Okay, and work done by Fe, that is equal to We is equal to force into displacement, that is equal to Fe into displacement is x2. So this Fe is QE x2. Now see, these two will be equal because this spring is getting energy due to work done by electrostatic force. What I can write? This half k x2 square, x2 square is equal to QE x2. So from here we will get x2 is equal to 2 QE divided by k. This is answer part 1. This will be the maximum extension in the spring. Okay? I am roughing. Now see, to solve second part and third part, we need to understand some concept here. You can see this is a spring, this is M. I am talking about the same system. Okay? What will happen? There is a force, electrostatic force. Now, at this position, this is the original length of the spring. So here F will be 0. There will not be any restoring force due to spring because this spring is in original length. Now, because of the selected field, it is getting force Fe, that is QE. Okay, having charge Q. So this block will start moving in this direction. So as soon as this block moves in this direction, there will be extension in the spring. Okay, this extension I'll be taking the value as x. Okay, so when this block starts moving in this direction, there will be extension in this spring, and due to that extension, there will be Fs. It will not be zero. So what will happen? Initially, when suppose this block is using at this position, suppose that value is xs. Okay, so at this point, Fs will be minus k x dash and Fe will be same. But suppose there is a condition. What is the condition? This Fs is less than QE. Then this block will move further, and you will get a position where Fs will equal to Fe. Listen again. When this block starts moving in this direction, there will be stretch in this spring. Because of that stretch, you will get restoring force due to spring. That value will be minus kx. Okay, and as x increases, we know Fs increases. As x increases, restoring force increases. So definitely you will get a position of the block when where this restoring force due to spring will equal to electrostatic force. Clear? That position, this position will be called as equilibrium position, or you may say mean position. Not equilibrium position, will be called as mean position. Okay, mean position. But due to inertia, this block will not stop here, and this will move further. Okay, and you will get this maximum displacement. So I am talking about this value as x2 here. This is x2, this was x2. Okay, I was talking about this x value. Okay, this was the maximum displacement. This was the maximum displacement. At this position, you will get mean position where spring restoring force due to spring will equal to the electrostatic force, and after some distance from this mean position. Why? Because of inertia, this block will not stop here. It will move further up to a value of x. At this point, this block will be stopped. Okay, and again it will move in this direction. Clear? So this is the maximum stretch, and this distance, suppose this is x1. Okay, so again I am drawing diagram so you will not get confused. This is mean position, and remember this distance will not equal to this distance. Remember, this is mean position. At this point, Fs will equal to Fe. Suppose the distance is x0, and I am taking this distance as x2 in previous part, and this distance is. So now we have to find x0 value. Okay, so x0 will be very simple. How? x0. So at this point, Fe at mean position. At mean position, Fs is equal to Fe. Fs is K x naught. This is the restoring force now. What will be the restoring force at this position? This is the original length of the spring. It gets stretched with the distance x naught. So definitely restoring force will be K x naught, and this will equal to QE. So here, okay. So from here we will get x naught is equal to QE divided by. This will be your distance of mean position. Okay, so this was the second part. This was the second part of the question. Now third part is we have to prove this is a SHM or not. Okay, we have to check this is SHM or not. Now see. So now I am going to solve for third part. What is the third part? We have to check this motion of the block is simple harmonic motion or not. Okay. So now you can see this diagram. I have drawn again. This distance is x naught. This is the original length of the spring. This x naught is distance of mean position from the original length of the spring, and this total x2, total distance is maximum stretch in the spring. Okay, so I am taking this distance as y. What is y? This is y is equal to x2 minus x1. That's it. Nothing. Y is x2 minus x0. Okay. So what I am going to do at maximum stretch, Fs is equal to kx2. Yes or no? Or you can write minus kx2. This will be the restoring force at this position I am talking about, because x2 is the total stretch. Okay. So Fs is equal to minus k. I am taking x2 value as x0 plus y. So Fs is equal to minus k x0 minus k y. Okay. Wait. Sorry. So Fe also Fe is equal to QE at this position. So if you draw FBD at maximum stretch, this will be Fe and this will be Fs. So this is the ability of this block. Okay. So if you see the ability at maximum stretch means at this position. At this position, what is going to happen? This block will not move in this direction. Okay. This block will come back in this direction. This is the maximum stretch possible for this spring. Okay, so definitely Fs is more than Fe, so F net will be Fs minus Fe, and that is equal to Fs minus k x naught minus ky minus Fe. But in second part we have seen that Fe is equal to, that is QE is equal to minus k x0 at mean position. We have seen this value in the second part. So now I am substituting this value minus kx0 minus ky minus Fe. So this will get cancelled. F is equal to minus kx0. Cancel F net. This F net will be minus ky. So again now, this F net is equal to minus k1. It is similar to F restoring force minus kx. Is this similar? Yes or no? This F, or I can write F net proportional to y, which displacement. And this net force is a restoring force because of this F net, this block is coming back. So this F net is restoring force and is proportional to displacement. Okay, so definitely this motion is an SH. This is the basic and necessary condition for SHM. If restoring force is proportional to displacement, definitely this that motion will be SHM. Okay, we have proved that this motion is SHM motion. Now we are going to solve the fourth part and the fifth part. Fourth part, amplitude. Amplitude means this is the escalator, this is mean position, this is the maximum position. At this position, it will come back and it will reach at the mean position. Again, because of inertia, it will move in this direction. Then again, it will reach at mean position at this position and will move like this, just like a simple harmonic motion. So you can see directly from this diagram, this y is your amplitude. Amplitude, that's y. Okay? You can get this value as y is equal to x2 minus x2. We have already calculated x0 in first part, x2 in first part, x0 in second part. You can get y is equal to x2 minus x1. Okay, this will be amplitude of this simple harmonic motion. And fifth part, time period. We know time period for simple harmonic motion is equal to 2 pi root m. There will be any change? No. There is a mass m only. Mass of this block is m. There is a spring having a constant as k similar spring. Okay? And there is nothing that can be changed in this formula. So you can have time period by this formula. That's it. So we have solved all the 5 parts of this question. Okay. So try to solve this question again. This is a very important question, a very good question.